Welcome to Want to Learn Chemistry, a site to help you become a chemistry expert. For the upcoming new specification 2015 OCR A exams, I thought of doing some questions and answers on the points that students tend to not get as many marks as possible, which are the 6-marker questions. Question 1. The third period of the periodic table features the elements magnesium and chlorine. The table below shows the melting point of these elements. Describe the structure and bonding shown by these elements. Use your answer to explain the difference in melting points. And 1 mark is given for appropriate technical terms spelled correctly. Now pause this video and answer this question using your notes and textbook. Now let's go through the answer. Magnesium has a giant structure. Metallic or delocalized needs to be spelled correctly. Magnesium has metallic bonding or description of metallic bonding as positive ions and delocalized electrons. There is electrostatic attraction between positive ions and electrons. On the other hand, Cl, chlorine, has a simple molecular or simple covalent structure. Cl has van der Waals forces between molecules. Or other ideas could be Cl has instantaneous dipole, induced dipole, or temporary dipole. Van der Waals forces are weak and metallic bonds are strong. Less energy needed to overcome van der Waals than metallic bonds. Question 2, which is worth 5 marks. One form of naturally occurring carbon is graphite. The table below lists some properties of graphite. Describe the bonding and structure in graphite. Explain in terms of bonding and structure the properties of graphite shown above. Again, requires appropriate technical terms spelled correctly. In your answer, you must say that giant covalent lattice, there are many layers, and each of the 3 properties below must be linked to the explanation. So if it's a good conductor, because it has mobile electrons or delocalized electrons, or electrons can move. If you mention high or low boiling point, high melting or boiling point, because strong or covalent bonds have to be broken. If it's soft, because there are van der Waals forces or intermolecular forces or weak bonds or weak forces between the layers, so layers can slide. Question 3, worth 6 marks. Water forms hydrogen bonds which influence its properties. Explain with a diagram what is meant by hydrogen bonding, and explain 2 anomalous properties of water resulting from hydrogen bonding. Now let's go through the answer. Hydrogen bonding from lone pair on oxygen of one water molecule to hydrogen of another. You need to show dipoles. Also 2 properties. Ice is lighter than water, and the reason being that hydrogen bond hold water molecules apart. There's an open lattice in ice, and the hydrogen bonds are longer. If you mention high melting or boiling point than expected, and the reason for this is that strength of hydrogen bonds that needs to be broken, it's stronger and higher. And last of all, high surface tension or viscosity. Explanation, strength of hydrogen bonds across surface. Question 4, worth 6 marks. The halogens, chlorine, bromine, and iodine each exist as a diatomic molecule at room temperature and pressure. The halogens all have van der Waals forces. Explain how van der Waals forces are formed. Explain the trend in volatilities of the halogens, chlorine, bromine, and iodine. And again, in this question, 1 mark is available for the quality of spelling, punctuation, and grammar. Pause this video and have a go at answering this question. Now let's go through the answer. A high boiling point or difficult to break, linked to strong bonds in the right context within lithium or carbon. So for lithium, you can say it conducts by delocalized or free or mobile electron structure. It is giant, metallic, or it has positive ions with the C of electrons. For carbon, you can mention it conducts by delocalized or free or mobile electron structure. It is giant covalent with layers. For nitrogen, no mobile charge carriers or electrons or ions to conduct electricity. Simple molecular structure, made up of nitrogen molecules. Low boiling point or easily broken due to intermolecular forces or van der Waals forces. To achieve the quality of written communication, at least 3 complete sentences in which the meaning is clear. And let's go over question 5. The dot and cross diagram of ammonia molecule is shown below. Predict with reasons the bond angle in ammonia molecule. This question is worth 4 marks. Pause this video, have a go at the question, and now let's go through the answer. Uneven distribution of electrons, instantaneous, oscillating, changing, temporary, transient, all of these words can be used. Dipole on one atom causes an induced or resultant dipole on another molecule or atom. Chlorine is a gas, bromine is a liquid, iodine is a solid. Volatility decreases from chlorine, bromine, iodine. Boiling point increases from chlorine, bromine, iodine. Stronger forces are broken from chlorine, bromine to iodine. Number of electron increases down the group, and greater or more van der Waals forces or induced dipole interactions or forces between the molecules. Question 6. In this question, 1 mark is available for the written communication. Describe the intermolecular bonding in methane and in water. Use clear diagrams in your answer. So again, visual will be very useful, and the examiners can see them very easily, so make sure you use diagrams, and it's worth 6 marks. Ammonia is 107 degrees because the electron pairs repel other electron pairs. Lone pair has more repulsion. Electron pairs get as far apart as possible, and most of the time the last 3 bullet points are correct. Only the bond angle might change for a question. Question 7. State and explain 2 anomalous properties of water that depends on its intermolecular forces for 4 mark and 1 additional mark for quality of written communication. Water has hydrogen bonding from oxygen of one molecule to hydrogen of another. Dipoles shown or described, so delta positive on hydrogen and delta negative on oxygen, with lone pairs of oxygen involved in the bond. For methane, van der Waals forces from oscillating dipoles or temporary dipoles or transient dipoles or instantaneous dipoles, leading to induced dipoles caused by uneven distribution of electrons. Question 8. State and explain 2 anomalous properties of water that depend on its intermolecular forces. I think I should just went through that. And this is a repeat of another question that was done earlier on, but I'll go through the mark scheme again. 2 properties. Ice is less dense than or lighter than water or floats on water, or maximum density at 4 degrees Celsius. Because hydrogen bonds hold water molecules apart, it has an open lattice in ice. Hydrogen bonds are longer, higher melting or boiling point than expected. And the reason being, hydrogen bonds need to be broken for high surface tension or strength of hydrogen bonds across surface. And again, quality of written communication or how well you write. Make sure you write clearly so the examiners can read and give you answers, and they don't have to look through your paper very thoroughly to understand what you're writing. Thank you for listening to me at Want to Learn Chemistry, a site to help you become a chemistry expert.